Okay, good afternoon, everybody. We're going to just wait a few more seconds here and make sure we get everybody on. I think we've got a pretty good attendance today. So we're just going to let a few more click in here and then we'll get started. Okay, I think we're good. Let's go ahead and jump in. First, I want to just welcome everybody. Thank you for joining us this afternoon. This is really our approach at an AIA course. We call this Introduction to DC Microgrids, how to integrate your latest renewable energy technologies into your projects. So this is a full learning unit credit for you. This is a health, safety, wellness credit as well. Really, everything we do on the DC microgrid concept is really going to be HSW certified. So look for more courses from us along those lines. Those will be coming up shortly. My name is David Lindsay. I'm the Chief Technology Architect for Aimbridge Energy Group. I am primarily focused on the system and the software design, the cloud connectivity, really all the AI intelligence that we have behind our systems. They just drive a lot of the intelligent rate management and movement from grid back to battery storage and that type of thing. You'll hear a little bit more about that approach that we have. Also, our systems tie directly into building management system and the SCADA platforms that are part of the buildings that we sit inside of. So all of that is controlled through our proprietary software engines. I also have with me Tom Osterman. He's our president, and also Joe Guller, our senior project engineer. And those gentlemen have an opportunity to introduce themselves here in a minute. So let's go ahead and jump in. Really, what we like to start with is kind of, I'd like to just talk about why we're here. What is our mission? What's Aimbridge Energy's core focus? And one of the things we talk about all the time is we really believe we're on the threshold of a significant paradigm shift in terms of the way commercial properties will need to manage their energy environment. So as you probably can tell, there's an upward pressure on the AC grid. More and more loads are being added on a regular basis to commercial properties, really residential properties as well. And this is just due to the addition of new building loads. As we grow and we become more of a digital environment, we add more and more loads to our building projects. And one of the biggest ones that we are seeing, and you probably are as well, is the addition of EV charging to commercial buildings. And one of the things we found is, according to many predictions, EVs will overtake ICE vehicles, the internal combustion engine vehicles, in total market share, really before 2030. That's more of a global scale look. We don't believe that the U.S. is probably scaling that fast, but you get an indication of where things are going. So that is going to continue to grow. So what I want to do here was just start off by giving a quick overview. We're going to be doing a building case study of a dealership project we have in Colorado. And I want to kind of give you a taste of what that's going to look like. What you're going to see here is a series of rendering images. These are all from our internal software tool called Revit, which many of you are probably familiar with. And so I just want to make sure you know that we've done all this. Is all a video rendering sequence that we've just taken stills from, just because the video renderings don't play real well over Zoom. And just do the file size. So at the end of this, if you're interested, we would be glad to share the video, full video rendering, and just kind of reach out and let us know that you're interested in that. We'll share that with you as well. So here we have the front of a dealership, and right here is what we call a solar smart structure. And this is an active structure. So basically this follows the sun throughout the day. We're going to get into that in more detail, but a very iconic element of the branding package that we have for commercial buildings. And then you can see kind of along the front of the building here, we've got a solar awning, and that is really just to kind of provide additional shade structure to the interior of the building and keep the utility rates lower and the heat inside the building lower. And then farther off in the distance, you'll see a solar canopy. And the solar canopy is, in this case, protecting inventory for this dealership, and it's got integrated EV charging as well. And this is all part of a branding package that we have for dealerships and for other commercial clients that we work with. So again, this is a snapshot of a rendering. You'll see the case study Joe will get into here in more detail as we go forward. So I just want to really quickly run through the agenda. For an AIA course, we really have outlined these primary learning objectives. And so we want to kind of walk through those with you. We'll talk a little bit more about who Aimbridge Energy Group is. We'll definitely want to get into what is a DC microgrid, so you understand the DC microgrid concept. And then we're going to get into some things like the higher economic, regulatory environmental issues that we're seeing today. And that'll give us an opportunity to touch on the lead certification process that's important to you all as well. And then we're going to spend the majority of the time on the case study and really walk through this building and look at the components of the DC microgrid system inside and out. And then what we're going to do is we're going to wrap up with Q&A. So I do want to encourage everybody to submit questions throughout. Just use the Q&A process, and at the end we will address those questions. And if we don't have a chance to get to those, we certainly will follow up directly with you afterwards. We tend to get quite a few, and so we'll work through those as quickly as we can. And then anything we don't get to, we will follow up directly with you after the class. And you'll see some poll questions pop up as well. If you want to answer those polls, I believe there's 3 of them as they'll pop up throughout. And then at the end, also an opportunity to schedule a one-on-one with us if you want to follow up and schedule an appointment. You'll have that opportunity as well. So what are today's learning objectives? So today there's 5 that we're going to kind of cover in detail. Certainly want to talk about what is a microgrid, and really Tom will get into specifically what is a DC microgrid and why are they different and valuable. So what is that DC microgrid difference? What does it mean in architectural design and building design? Another learning objective will be to gain a deeper understanding of the economic environmental impacts. We will definitely want to get into that. Regulatory and safety standard will be another topic we'll touch on. And then you get to see why the microgrids impact load management in DC equipped buildings, how that kind of works with the actual implementation of a real world project that we're working on. So who's Aimbridge Energy Group? We really think of ourselves in 4 primary areas of expertise. We're certainly product providers, engineers, energy systems manufacturers. So we build these systems from the ground up. We are experts at the engineering side. But then we take that further. We're also consultants. We're industry experts. So we basically become long-term partners with you or with your clients throughout the entire project. We're system integration experts. I talked a little bit about that. So we control the ecosystem from the hardware all the way through the software side and managing these systems throughout. So we have a full end-to-end solution, including the cloud integration, building management system integration, et cetera. And then really we're operational efficiency professionals and branding and marketing experts. And you know, the branding thing is probably not something you would typically expect to hear in a DC microgrid presentation. But we really believe deeply that the renewable energy face of a business changes dramatically with our solutions and just sets your client businesses apart as forward-thinking, modernized businesses. And so there's a really significant impact with the branding element as well. So I think it's also very important. All of this is really driven by our 3 core value propositions. So long-term operational efficiencies, we certainly bring to the table. Enhancing business continuity and avoiding revenue loss. So beyond just ensuring that there's additional efficiencies for the building and that there's operational cost mitigation, there's also this business continuity concept, so that your clients' buildings can continue to be up and operational in the event of any sort of power outage. And we're seeing brownouts, blackouts, obviously weather events on a regular basis. And so these systems allow businesses to keep operational, very, very foundational. And then brand differentiations I touched on, the ability to separate yourself. We're working on this dealership project right now. And dealerships struggle tremendously to separate themselves from their competition. And so putting this new face, it's a refreshed look for a dealership, is critical for them at this point in time. And really, most commercial businesses are looking for the same type of an approach. So those are our 3 core value propositions. And you kind of see them ring true throughout this process. So I've already introduced myself. I want to now give a chance for Tom and Joe to quickly introduce themselves. Tom, would you just start off by giving a quick intro to you, and then we'll have Joe jump in.
Absolutely. Thank you, David. And thanks to all the attendees today for your time and for participating. My background is in critical facility power conversion design and implementation. I built data centers, communication facilities, pretty high reliability installations that had really high power density. Also managed a manufacturing company that built a lot of essentially DC microgrid components and power systems for telecom that use DC. Joe?
Yeah, thanks, Tom. I'm Joe, and my background is in the industrial power and telecom industry, focusing on DC power, hybrid, renewable, and battery backup systems. And here at Aimbridge, I work directly with clients through initial consultation, design, scope, through construction, and then beyond. So let me hand it back to David and we'll continue on.
Okay, great. Thank you guys. Appreciate that. All right. So what I want to touch on next is just kind of outline what we think are the core problems. There's really 7 kind of high level problems, and then we're going to get into some of the details of the microgrid in the case study. So really, none of these things are going to be shocking to anybody. Grid availability continues to be a significant issue. There's a ongoing issue with grid availability. We're continuing to see this degrade day by day. So this particular first bullet, North American Electric Reliability Corporation, they reported that grid outages reached 9% in 2024. So that's really the highest that we've seen in a decade. And so predictions for 2025 were certainly higher than that. So we'll see how that turns out. Longer downtimes have also increased as maintenance issues and technical malfunctions plague utilities. We see this all the time. And last year, the average downtime was 6.5 hours per customer. And of course, that leads to ongoing lost revenue and significant issues. Number 3, increased demand over the next decade. And again, this is per NERC. The demand for energy is expected to increase by 18% over the next decade, which only inflates the percentage of the outages and downtime. So there's just a compounding effect with the growth. We know building loads are increasing with the addition of EV charges, which I touched on earlier. The addition of EV charges to the energy landscape, loads have increased significantly. And obviously that's more for commercial buildings. Residential homes also have this impact, but there's a lot of regulatory mandates to now add a certain number of EV chargers per number of parking spots in your commercial buildings. And so that will continue to push on that load. And then the other problem is utility companies are starting to prioritize certain projects over others. So data centers, critical infrastructure. So data centers tied to AI compute, servers and chip manufacturers and those types of businesses are getting utility preference over other projects. And so we'll kind of touch on why the DC microgrid approach allows you to continue to build and keep your projects on track without necessarily 100% utility reliance. And then, of course, pricing increases. US electricity prices, it looks like they increased 3.6 over last year. So this is a 2024 number. That's higher than the broader inflation rate of 3.2%, which is pretty significant. So that's something that we'll only continue to see increase over time, which is probably not a shock to anybody. And then one of the things that's probably most obvious to everybody on this call is that new building energy codes are complex and they're costly. Energy codes change constantly. It's almost impossible to keep up with this. And we understand they're very different at a local level and a state level. And then there's obviously federal regulatory changes that get pushed down. And so what we do is we really watch these things, and we are experts on this, certainly at the federal level. And then we have certain states we really drill down and understand at the local governance level what's going on with those energy code and regulatory changes that are going on in the market. And so with that, let's just jump into some of the more detail on the microgrid side. Tom, if you wouldn't mind walking us through what is a DC microgrid and the microgrid concept, we'll do that next.
Absolutely. Thank you. So let's start with the name microgrid. It is kind of means what it says in that it's a analogy to the greater national electrical utility grid, but it's a smaller version of it. So if you look at what is contained in the normal electrical utility grid, you've got generating resources, whether it's coal or hydro or wind, solar. You've got long distance transmission, high voltage transmission, and then local distribution and direct connection of load, electrical load serving in a residence or a building. So think of a microgrid as kind of a utility grid in a box, best way to say it. It's got a lot of those components, but is at a site level or on the edge of distribution. So it's close to facilities or included in a facility. So this graphic on your display that you see now shows solar power, photovoltaic solar panel arrays generating energy. And that energy is controlled and regulated and feeds a lithium-based energy storage battery system. And then that output is feeding our loads at this particular building location. If you look in the lower right, you can see some icons that represent loads that can be fed with direct DC instead of traditional AC. In the upper right, you'll see AC loads that can be fed with an inverter system that converts DC to AC. Every building has legacy AC loads that can only be AC fed devices. So this particular configuration allows us to feed some of those loads with traditional AC by inversion, while preserving the goal to have the majority of the loads actually powered by DC instead of AC. The next slide shows operation when there's no generation. So if there's no wind, no solar, and we're just operating the loads from the battery storage that we've charged up with renewable generation during the day, that shows the power flow from the battery through the load distribution system to both the AC loads and the DC loads. So that's nighttime operation in the case of the solar context. And if we don't have any utility power present. The next slide shows an interesting alternate use case or power flow configuration, and that shows utility power feeding the microgrid system and adding in battery recharge. So if you have no solar, no wind, no renewable generation, or if the system's down for maintenance or has a fault or has a problem, we have a bypass capability where we can have the AC power from the utility feed a rectifier, which converts it to DC, which charges the battery system back up and also continues to support our AC and DC loads. It's important to note that that's kind of a bypass where the utility is our backup system now with this scheme instead of being our primary source. And this is a behind the meter system. You'll hear that a lot. And what does that mean? Well, what we're trying to do is generate our own power on site and then store that with energy storage and deploy that to our loads and avoiding paying the utility company for that energy, which allows us to generate it at lower cost and control that process and reduce our exposure to utility reliability issues and grid scarcity and certainly kilowatt hour cost escalation. So a summary is a microgrid system. Think of it as being similar to an uninterruptible power supply or a generator system. It's got similar aspects in terms of power conversion. But what it's really designed to do is to accept different forms of renewable energy generation input, control that power flow, and regulate that appropriately to charge stored energy systems, which are typically batteries, and then control power distribution to the loads. And when you ask the question, well, why is that any different than, what we do today? The key difference here is that we're trying to use DC power instead of AC. And that's been facilitated over the last 30 to 40 years by dramatic advances in semiconductor technology, and the efficiency of that operation has increased dramatically. So we can operate many load devices now on DC. In fact, they're already operating on DC. If you have a wall wart kind of plug-in transformer or power supply that's fed from AC from the wall socket, the output is feeding DC to a particular load. LED lighting over the last 20 years is primarily low voltage in many residential and commercial applications, 24 volts DC or 48 volts DC. So a microgrid concept, particularly a DC version, is far more efficient. We're eliminating those power conversion steps. We're operating at a lower voltage, and it provides resiliency and reliability at a client site integrated into their electrical system. So this is a picture of what the microgrid cabinet in our configuration looks like. That's a 25 kilowatt integrated cabinet system. You'll see what looks like white drawers kind of on the lower section of the cabinet. And those are batteries. They're modular and hot swappable. Higher up in the cabinet are DC to DC converter modules and rectifier modules. And there's a touchscreen decision engine supervisory controller. My earlier analogy was this is kind of a grid in a box, and it's really true. We have all the elements of generation, storage, control, distribution, circuit protection, overcurrent limiting, like you typically would see in a larger electrical system. So what does it do for us? We have that DC to DC efficiency. We're reducing those conversion losses, and unlike traditional rooftop solar, we're not converting primarily with a AC inverter all of the energy we generate from solar. It's resilient and scalable. We've got the ability to add or delete battery capacity and add power conversion capacity. So this can grow with the load or changes at a customer site. We've got cloud-based decision engine capability. And why would you care? Well, this box can reach out to the cloud and understand weather patterns, can factor in utility grid cost, time of use, tariff numbers, and can make some decisions on how to manage power generation, storage, and power flow. So it's a smart box, so to speak, in that it's cloud connected to the outside world and uses that leverage, and particularly the AI-based information that allows us to make really good operating decisions to maximize the efficiency and the benefit of this. We have smart load distribution. We've got circuit breaker distribution with load detection, so we know how much load per breaker and how the loads in a particular building are behaving. So it's like a smart breaker panel, if you will. We have an optional grid tie connection if we want to push power back to the grid. That's not the primary mission of a behind the meter system, unlike traditional rooftop solar. But we do have that option if there's excess generation and we do want to sell it back to the utility, we can deploy that configuration. And finally, we've got deep energy storage. If you look at what's happening in renewable energy, and particularly rooftop solar, it's all about adding deep storage and the ability to store energy and deploy it on an as needed basis, and to manipulate when we store and when we use from a cost perspective and reducing utility costs. The next slide talks about kind of the economic and environmental impacts. And as architects, you're very familiar with all these design trade-offs and value engineering. We've got operating costs, capital costs, return on investment, energy efficiency decisions. Does the client project require resiliency and reliability? In other words, continuation of business operation, the battery backup function, and the ability to ride through utility outages and be self-sufficient with internal backup. The resiliency issue also resonates with architects. I'm sure many of you that are dealing with residential development design work know that that's kind of a trendy thing right now is resiliency hubs in community developments. It's a place for safety if there's a weather event or utility failure or power outage where people can come. There's heat, there's hot water, there's electricity to operate, charge phone devices, refrigeration for medication. It's a hardened, safe facility from an energy perspective that allows for community benefit. And then finally, a lot of your clients are very aligned with improving, our economic, not our economic, our environmental footprint. I'm sorry, our carbon footprint. Doing things that are beneficial to the environment, reducing carbon output, and transition of load to beneficial electrification. That resonates with a lot of your clients as a goal, design goal for many of your design projects, I'm sure.
Yeah, and just as a follow-on comment there, the face of this system, as I've kind of touched on with the solar structure that we've got placed in front of buildings and the iconic sort of look of some of the more modernized solar installations and canopies. Not only is that carbon footprint offset a big deal for your client as a business, but also to their customers. And so the connection between client and customer and that face of the business that gets just modified. And I would also say that you as an architectural firm, if this is a specialty area you would want to bring to the market, brand yourself with this sort of look and feel for your clients, and that this is one of your specialties, and we partner with you to help get that done. So really just changes the face of your business and your client's business with these with a very hot topic, obviously, right now with customers. So
Yeah, that's a great point, David. And that's a perfect segue into the next slide, which is the rest of the story. So you have client-facing benefits, you've got operational and reliability benefits, and we also have code compliance. In order to design a project and successfully get a building permit and construct it to code, We have safety codes, we have reliability standards, national safety agencies that we have to comply with. So as design professionals, we all know how that works in terms of the subdisciplines in an architectural design and how that all has to adhere tightly to the national code side, but also local, state AHJ or municipal AHJ and state codes. The other side of this is just regulatory in general that we're already used to, such as the NFPA from a fire protection and fire safety perspective, green building standards in terms of accomplishing some beneficial design that's greener than a traditional construction. Certainly, ADA compliance has been in your lexicon forever in terms of designing appropriately for compliance there. But in addition to all that, what's new and what's really putting a lot of pressure on design professionals is energy codes. And that is really evolving quickly. And it's certainly a state by state story, but it's also being driven globally and international codes that are harmonizing the design process and compliance, are all around the world. Certain states are more aggressive or progressive in this area than others. But the point is, in order to obtain a building code, now you've got additional compliance requirements you have to be cognizant of in terms of energy efficiency, implementation of renewables, EV charging capacity reserve. And certainly, you're very familiar with insulation and glazing and all the things that you can do to comply with a energy efficient structure design. And some of them are outright very aggressive in terms of now mandating heat pump hot water tanks, for example, that are more energy efficient than resistance heating, or mini splits or compressor driven HVAC systems that are more energy efficient, reserving capacity in your electrical distribution system for EV charging, or actually having to install a certain number of EV chargers at a client site. So, in addition to what we're all used to as architects and design professionals, now that there's a whole new overlay, which is the energy designed for compliance and designed for client preference, and also, as David mentioned, their clients in turn, and being able to have that be visible. Back to the idea of that active generating sculpture and the visibility of these renewable systems at a client site that tells a message that the facility is green and is compliant and is embracing the future and is designed to be responsible for the environment. Another one that's right in your wheelhouse, certainly as an architect, is LEED certification. This is a huge deal for client objectives, but also for architects to differentiate yourself and your practice and how many of your projects achieve certification levels. And that's all about energy. It's about efficiency and sustainability, and it's all tied into the same global movement in terms of improving how we design and build buildings and how we're responsible in that design approach, and particularly in how we implement energy savings, energy efficiency, and sustainability. The certification process continues to get more and more and more complicated, and which is good. We're raising the bar for compliance as architects in terms of achieving even more in terms of innovative building design and energy efficiency. And now that's including a lot of the renewable energy device overlay details as opposed to just insulation and glazing and things like that. This is now active energy systems that are part of the compliance checklist. And in many cases, the renewable investments, particularly a DC microgrid, can help with that scoring methodology where it has an outsized impact on score compared to other traditional energy efficiency or just building design efficiency issues. So the whole point is that renewable energy and energy storage, decarbonization, EV charging, all of those attributes are now a really important part of your client preference and objectives, as well as to differentiate your practice as an architect. We're going to move into a case study, as David has been talking about, which is a very specific location and a design process that was quite innovative. And we're going to walk through for the rest of the webinar today how that went, what the attributes are, how it worked, and how it aimed true to what we're talking about in terms of architectural design excellence.
Yeah, great. And thank you, Tom. That's a great walk through the details of microgrids and the entire regulatory process. It's obviously a big topic. I want to mention that, the purpose of this is to give an overview. We understand there's a significant deep dive that would need to be done with you individually to try to understand your regulatory environment and the issues you're facing. So Tom and the rest of the team were expertise at getting into that with you. So the case study that we want to talk about, again, is an automotive dealership. I want to touch on the core kind of issues that we're trying to solve here. And so the first is just poor building aesthetics. This particular dealership had a very dated facade, just a bad, kind of a dated look, and sort of just didn't pop when you drove by on the street. There was really poor lighting, the old sodium lighting set up inside and out and on the lot. The lot was dark at night, and obviously for a dealership, you want a lot of nice bright light that spreads out across the entire light, both for shopping and for safety and security. Definitely seeing rapidly increasing utility costs as a business, lack of brand recognition among dealerships in the market. So that it's kind of a high tense dealer area. And so they just didn't stand out and have a different kind of look and feel for their customers. There's definitely concerns of grid outages and weather events, quite a bit of weather in this particular area in Denver. So some outages based on storms passing through that they wanted to avoid. And then really the goal, and this is really something we're seeing with commercial buildings in general, but automotive dealerships, is the need and the desire to add EV charging facilities. And so part of this project will be DC grid tied charging facility additions for these dealerships. So you'll see some of that. So this particular dealership is a 28,000 square foot building. It's in Lakewood, Colorado. There's already a 36 kilowatt solar array on the top. That was a project that we completed kind of as a phase one for this dealer. This remodel, we will add 2 DC microgrids. You'll see that Joe will kind of touch on that, 125 kilowatt and 115 kilowatt microgrid. There will be 3 canopies with dedicated EV charging. That 3 canopies will add an additional 48 kilowatts of solar and energy to the entire ecosystem of this project. Battery storage will provide over 240 kilowatt hours of energy when we're all done. And so then there's a total of 100 kilowatts of power generation from on-site renewable energy sources, which really is going to help this dealership remain and survive off-grid as much as it needs to. So at the end, system will have the capability to power interior LED lighting, parking lot lighting, EV chargers, and then of course we really want to make sure we incorporate security cameras, IT infrastructure, that kind of thing, which is all very DC ready types of systems. So they're very easy to plug in and be a part of this ecosystem. So next, I'm going to have Joe. Joe, if you wouldn't mind kind of walking us through these rendering files, and we'll take a look at what this dealership looks like throughout this project here.
Sure. Thanks, David. So let's start at the front. We're positioning this solar structure right at the very front of the dealership, which is highway facing. So this is going to provide maximum visual impact and client identity. And it is a solar tracker, but it's also a kinetic sculpture. It actually moves and follows the sun throughout the day. It can close up all of its petals if it gets windy or at nighttime. And it creates a narrative around innovation and sustainability as soon as you walk onto the lot. This system generates 4 kilowatts of solar and includes battery storage inside the pedestal base. And it works independently of the utility grid, either as its own standalone clean energy asset or as a contributing node in a larger site for the larger site-wide microgrid. And the pedestal wraps, so you can put your own branding on the pedestal wraps, and they can be used for permanent branding or seasonal marketing space. So it's really more than just a piece of equipment. It's an icon, and you'll see it used worldwide in everything from museums to corporate campuses, retail centers, schools. This is just a really valuable tool that you can add to your projects, and it supports LEED initiatives without interfering with the building massing or layout. So moving on to the facade, this dealership faces south, which creates a lobby overheating issue. So we're solving that with a 10 kilowatt solar awning that also doubles as passive shading. This provides measurable performance benefit both in energy yield and HVAC load reduction, while integrating cleanly with the storefront glazing and canopy line. It aligns with both energy code requirements and helps the client's branding needs. And beneath the solar awning, we're installing level 2 EV charging pedestals to serve guests that will be powered from the solar. And this isn't just functional infrastructure, it's also part of the dealership experience. Customers arriving in EVs can plug in, relax, take their time, engage with the showroom. And it's also a suitable but effective ESG compliance strategy that aligns with OEM and municipal expectations. So a great way to increase your score there. And what, like David was saying earlier, inventory charging for the EV or the dealership industry is becoming a bottleneck. We're going to address that with solar shade canopies out in the lot. This is an example of a 24 kilowatt configuration combined with 46 kilowatt hours of battery storage. And these structures power daytime inventory charging cycles without straining the building's utility service. And then
Yeah.
underneath, yeah.
Oh, I'm sorry, Joe. I just wanted to jump in just real quick. One of the things that I love about these, this is probably one of my favorite elements of our product line and the things that we do for clients. Just the immediate iconic change to the look and feel of a parking lot, and it doesn't have to be a dealership inventory lot full of cars. It could be obviously parking for customers and that type of thing. But it's such an immediate and modern look for a dealer. When you see these things up in live and in person, they're just absolutely incredible. And then the ability to integrate these EV chargers into these systems, it's really one of my favorite things that we're doing. And I think that it's going to be probably one of the most popular things. Dealerships is a great place for it, but we're also having some interest in just larger parking structures. And so I just think it's such a great dual purpose solution. I just want to comment on that. Sorry, Joe.
Yeah, no, and they look really good at night too. They have LED lighting underneath.
Yep.
One of the other things that's really neat about this system is that all of the wiring is completely contained within the structure itself. So which is really important in high traffic, customer facing areas, just a really clean balance of system. So what you're seeing underneath here is a fully DC coupled charging system. This is solar energy is collected and delivered directly to the car's battery without any AC conversions at all in the process. So this skips all the AC to DC stages that level 2 chargers have. By eliminating those steps, we can shorten the charge times and increase the total system efficiency and allow the business to get more cars cycled through their regular maintenance and inventory top-off cycles. And like I said earlier, from a design perspective, this canopy serves multiple roles. It's generating power, it's providing weather protection, and everything's integrated neatly into the structure itself. So let's move on. This is the heart of the system here. This is the compact, fully integrated DC microgrid cabinet, and it's located inside the dealership's electrical room. This combines the rooftop solar input, wind, and battery storage, and it has smart load distribution and a system supervision and all inside a single cabinet. So one of these cabinets is capable of 25 kilowatts, and it can operate independently, or you can stack additional cabinets next to it, or in other locations if you want to increase the power. It also, like we said, it has the power to draw supplemental backup power from the grid, but it's designed to prefer any renewable source if it's available. And this format just eliminates the need for multiple wall-mounted system components that you'd see on a similar solar system like this. And it integrates cleanly into your MEP plans, takes up minimal floor space, and connects the building management system it's capable of load prioritization and system monitoring. So out in the lobby, we replaced the legacy fluorescent lighting with a fully DC powered 24-volt lighting system. And these are high efficiency 2x2 troffers designed specifically for low voltage direct current. And the result is just an exceptional lighting quality, zero flicker or glare, full dimming range, and all while reducing the upstream conversion losses typical from AC lights, even AC LED lights. From a design and infrastructure standpoint, using a low voltage system like this allows for simplified NEC Class 2 wiring infrastructure above the ceiling grid. So that's also an added bonus there. This approach reduces heat load, simplifies the ceiling infrastructure, and it's really a clean, efficient lighting strategy.
Yeah, and this particular part of this project is actually done inside this sales floor at this dealership, and so we've had a chance to say I've had a chance to go in and see it. I've seen the before and after, and I can just tell you it's absolutely incredible. It changes the entire experience inside that building, both for the employees and for the customers. I mean, there's just dark drab corners in the corners of the sales floor. Everything is now bright. It's warm. The LED drivers that we have in these systems, which control. Joe will touch on here briefly, but really control the light temperature and the ambiance. So I just we actually think of this as a part of our branding package as well, because the lighting, both inside and out, becomes such a critical component of the facade and the look and feel for the commercial customers, employees and clients as well. So just such an amazing difference just with this one simple move.
Yeah, and the high density lighting chips in these lights you just get a perfect smooth, no hot spots, no glare. It's
Yeah.
just perfect diffusion throughout the whole light fixture. So also in this building, we've implemented a 48-volt PoE network, and that's powering all of the Wi-Fi access points, digital signage, and office equipment. And one of the key advantages about DC-based power over Ethernet is that it's entirely compatible with all other existing PoE standards, meaning you can spec the same standard equipment and integrate it seamlessly into the microgrid without any proprietary interfaces, just the 48-volt PoE switch. We've also embedded USB charging into the guest seating area, and this creates a really user-friendly environment without adding any surface clutter or AC infrastructure. So it's really great for customer lounges and just relaxing, and it really gives it a modern waiting area kind of experience. So outside, let's take a look outside. And so we're just looking at the exterior of the building here. The original security system was just, basic alarm keypads, analog cameras, no battery backup, no network visibility, and real limited user access control. So we're also upgrading this also to a fully networked 48-volt PoE-based security suite. And that will include IP cameras, badge readers, magnetic door locks, digital keypads, and all of that will run natively on the same DC microgrid infrastructure as the rest of the building. And by powering everything over PoE, you can simplify all the wiring, conduit routing, everything can just data and power can connect natively without any AC infrastructure to support all of that. So it's really a good efficiency from a building design approach. Also, it's really easy to scale up in the future as well. And then now on the next slide, this is just representing the outside of the building. We have both emergency egress lighting and PoE cameras on the outside. These are also powered directly, but they're powered on a dedicated 48-volt backup bus. And that 48-volt bus is prioritized over all other loads. So in the event that there's a grid outage and solar's not available, say there's snow for a few days or something like that, it will prioritize this system to ensure all of the most critical building functions are maintained for as long as possible. And then on the next slide, it's just a picture. This is a PoE camera integrated onto the lighting pole, and it's also running on the same 48-volt DC power. And this allows us to leverage the existing lighting infrastructure for both illumination and surveillance. So it keeps everything clean and consolidated. And all the devices are addressable through a central network for just centralized monitoring and remote access to all the cameras. So here's a picture of the rooftop solar. And like David said, this is a 36 kilowatt solar array. This is using a ballasted racking system, which means no roof penetrations and no flashing or structural modifications needed to be made to the roof. So that keeps the building envelope intact. This array is a primary energy source for the DC microgrids inside the building, powering the interior lighting, security infrastructure, and IT systems. And then here's a picture to complement the solar. We're installing some vertical axis wind turbines. These are fairly small. They're each rated at 1 kilowatt each, and these operate during cloudy days and nighttime hours when solar is not available, kind of helping to augment and stabilize the microgrid's power supply. This is a compact design, and it allows the turbine to generate wind no matter which direction it's blowing. These are connected to little solar generators in the power room with the microgrid, and they output DC power. So because of that, they're able to be stacked right into the microgrid system without any kind of switchgear or synchronization needed like you would normally have with an AC based system.
Yeah, and I would just add here real quick, these wind turbines are being depicted here, and this project will potentially have these up on the roof, but that's not a requirement, obviously. So we see a lot of clients interested in having these wind turbines really sitting out in front of the store, somewhere on lot close by the building that just basically gives that, again, an additional iconic look, just that brand signaling to let them know that they're focused on the renewable purpose and carbon footprint reduction. So lots of places to put these things in your projects.
Yeah, absolutely. And a ground mount vertical turbine like this is actually very visually striking as well.
Yeah,
So
yeah.
so definitely good for the branding initiatives. So, okay, now we're looking inside the service garage, and it originally had high pressure sodium lamps, which ran hot, consumed a lot of energy, and had constant maintenance issues with ballasts and bulb replacements. So we swapped all that out with 250-watt LED high bay fixtures, each delivering 50,000 lumens. But instead of powering them with AC like most retrofits, these are running natively on a 48-volt DC, which is coming from the microgrid. And that eliminates all of the fixture level AC to DC conversion losses and thermal stress. So by not doing the conversion at the fixture level, we're not generating heat at each fixture, and we're using a much higher quality version of DC power that's feeding these LEDs. So you end up with a higher reliability, longer lifespan, and even all of these lights, these even at 250 watts per, this adds up to 10.5 kilowatts, and that's completely removed from the AC grid. And then we're also installing level 2 EV chargers in the garage to support on-site charging for the dealership service vehicles. These are powered directly from the microgrid, but through an inverter. And as Tom was saying, we're able to power any legacy AC load as well as DC loads. So it just speaks to the flexibility of DC microgrids. So it's a really clean loop here. The sunlight powers the roof array, energy flows to the microgrid cabinet, and service fleet charges right in the garage. So, all right, this is the final phase of our renovations, and we are planning on building a dedicated outdoor microgrid system to power all of the dealership lot lighting and security cameras. Each security pole includes either 3 or 4 high efficiency LED fixtures and a network connected point tilt zoom camera, and that's going to be routed through the PoE network for monitoring, of course. And then the lighting system will be powered by 2 additional shade structures in the back. These are split apart, but they total up to 24 kilowatts. And these are feeding a microgrid, and it's housed in an outdoor weatherproof enclosure. And we can take a better look at that on the next slide here. So you see that right in the middle. So this is a NEMA 3R outdoor power cabinet. It has enough battery storage to keep the lights and cameras running for up to 2 full nights if there was an issue where solar wasn't available. But like the indoor microgrid, this can also fall back on grid power, giving us resiliency for lighting and security. So that's the walkthrough of our project. So I'll hand it back to David for a wrap up.
All right, great. Thank you, Joe. That was great. So before we get into Q&A, which we'll do here in a second, just to wrap up that case study, just to kind of touch base on that project and really the size of it. It's a 28,000 square foot dealership, existing 36 kilowatt array. This remodel of 2 DC microgrids, 48 kilowatts of solar from 3 canopies, battery storage of 240 kilowatts of energy that's going to be made available to the building, and 100 kilowatt power generation from on-site sources. So pretty significant change in terms of the additional power that's going to be added to this building through renewables. And at the end, we will have addressed these concerns. So this will be a very modern looking dealership, and you can just tell that from these renderings. A robust DC powered LED lighting, both inside and out. As I mentioned, the inside is done. It's already making an incredible difference with this building. Utility cost management with the intelligent energy system in place will be driving those utility costs down. The smart flower, the structure that we have in front, is going to be an incredible brand change for this dealership. and then the ongoing resiliency tied to the offloadability during the outages and weather events that are typically occurring in this space. So they just kind of wrap up to that. And again, I do want to remind you, if you're interested, please reach out to us. We'd love to share the video file of this rendering walkthrough, and we can talk more about that with you at that point in time. So now we're about 11 minutes left here in the call, 11, 12 minutes. So Tom, if you wouldn't mind taking over, let's look at some of the Q&A that's come through, and we'll kind of start to address some of the questions that you all have, and we'll go from there.
Sounds good. Thank you, David. So one that came through that is really common with these webinars is kind of a fundamental question. Why is the DC microgrid system better than traditional rooftop grid connected solar? As we talk about microgrid implementations, and particularly with solar, in the design arena with architects, engineers, they go, oh yeah, we know what that is. That's rooftop solar, that's grid connected. You have an inverter that pushes power back onto the grid, which is true. But that whole market is evolving extremely quickly. The utility companies nationally are pulling back on how much they'll fund self-generation in terms of what energy you push back on the grid that runs your meter backwards, or what they will pay you for. In some states, that model has changed really dramatically to the point where it doesn't make sense. So that's one differentiating factor here, is that we're not trying to generate and push power to the grid to then get paid for that energy that we provide to the utility company. So the other part of the problem is those traditional rooftop systems are designed for safety and utility lineman protection and fire safety. And so if the utility goes down, if there's an outage, a grid problem, the inverter system is designed to self-island and shut itself off so that it doesn't continue to push power back onto the grid from a safety perspective until the outage is resolved. And so you may have full solar production during the day, a utility outage in process, and an inverter that's shut itself off. So you don't have any use or ability to use the solar generation that you may have. Where that gets into a real issue is in areas where you have a weather event, which was responsible for causing the utility outage. Now you've got utility power down. You may have the ability to still generate viable solar, at least during the day, but your lights are off and your facility is without power. So the deep energy storage gives you that capability to continue to operate and to be behind the meter, to be able to generate your own power, store it, use it, deploy it as you need, and be completely decoupled from the utility. So that's a huge difference. We're not just solely connected to the grid as a utility electrical kilowatt hour cost play. This is a system behind the meter that generates, stores, distributes, and we use the grid as basically our backup. Next one that we get a lot, right behind the first question, which is kind of funny, is why use DC instead of AC? Because that seems counterintuitive. You know, for 100 years plus, we've used AC globally. Well, technology has changed so dramatically over the last 30 years that now we can step up voltage, step down voltage, do power conversion with high frequency semiconductor-based converter systems that are really efficient and very reliable. So in years past, we really didn't have that capability. So now feeding devices and loads with DC is really cost effective and viable. And you look at the number of devices that are in a residence or a building that are natively DC anyway. When you look inside the box, you know, a monitor, a computer, you know, pick any type of load, the front end circuit on the inside is DC anyway. So we're doing this AC distribution to a DC conversion, and that loses efficiency when you have a conversion step. So using DC is much more efficient. It's really easy to couple multiple energy sources and storage sources, energy storage and loads together electrically. You don't have the sine wave synchronization at 50 or 60 cycles from an AC perspective and all that switchgear complexity. So paralleling AC sources is really expensive and complicated electrically. And these systems are super simple to connect a DC source to a DC battery to a DC load. Let's see here what I got next. the wrong button, sorry. The next question. Um, can EV chargers be powered by DC microgrids? And that's definitely a yes. Depending on the type of charger infrastructure, level two chargers are really an AC output. They're feeding a charger that's in the vehicle itself. So there's an on-vehicle battery charger. And that type of EV charger is really just kind of a programmable relay that allows 240 volt AC power to flow into the car's onboard charger. Um, in a residential context, and certainly even in commercial, retail, et cetera, you have a lot of these level two chargers. They're fairly limited in capacity. They don't recharge the car like a supercharger or fast charger would. But they're very common, and I think it's going to be the majority of the charging infrastructure that grows over time as the EV industry grows. So we can power these with a microgrid, and the charger configuration can accept DC on the input, has an internal conversion system, and provides 240 volts AC for the level two output. So that's effective to be able to use the advantage of the behind the meter microgrid to pick up that EV charger load. Certainly in the dealership context, as David mentioned, there's a lot of focus on EV sales and EV charging on the lot in the service bay. But for architects that are designing really any building structure, whether it's residential, retail, commercial, you've got code compliance mandates anyway, where you have to put in a certain amount of DC, or not DC, but just charging in general for EVs. And many of the codes require kind of a make ready, pre-installation of conduit or readiness to add additional charger capacity over time. So it's with us for good now in terms of that, supporting that EV charging load. And these microgrid systems do a great job for that.
Tom, I've got a question here. This comes up a lot. The solar structure, the smart flower concept, and the design of that. Maybe you could just talk to the size of that and kind of the footprint and what that kind of looks and feels like in a real world environment on a commercial property.
Yeah, you've got various mounting structure options for PV for solar panels, right? We can put them on a rooftop. We can put them on a ground mount bracket or stand structure, as you see in large utility scale solar. We can put them on an awning, a shade structure that's attached to the building, an awning environment, let's say, or portico, or on a trellis. We have all these different mounting surface options to integrate solar panel generation locations. The active sculpture approach, the smart flower, is innovative in that it actually tracks the sun. So it's very efficient at its conversion of solar energy to DC output in every solar day because it's always aimed at perfect alignment as the sun traces across the sky. The shade structure approach is also interesting in that it's multi-purpose. It provides a structural steel canopy frame to hold solar panels mechanically and at the right azimuth or angle towards the sun. Also provides shade and value there and hail protection for anything that's under the shade structure. And they also are kind of an aesthetic design statement. I mean, you see a lot of shade structures that don't have solar that are just part of the site design and the implementation of a particular design approach that's integrated with the building. They just look very high tech, very clean and green, and they tell a message. There's a design language there in terms of what they can communicate
Yeah.
in terms of a site design to a client, particularly retail. You see a lot of them in retail environments, separate from what we've discussed today with the car dealership environment.
Yeah, they're pretty amazing when they're fully open and pointed towards the sky, and you watch these things slowly kind of unfurl and close up, and it's a pretty amazing, iconic look for a property for sure. Really cool.
Let's see
Hey, we
here.
have time for another one.
Yeah, let me look. Here's a good one. So how does the energy storage work for a DC microgrid system? And what we've shared today, it's somewhat generic with kind of the icons, but these are all battery-based systems. They're typically a lithium battery configuration, very similar to what's in an EV in terms of battery type, with some technical differences. But the important point from a design and permitting and architectural perspective is that electrical storage costs are dropping dramatically globally due to growth of volume and economies of scale. So we're finding that's really cost effective to add storage, which is a game changer. 5 years ago, that didn't pencil out, and now it does. And that's what really makes this microgrid viable is the energy storage and the ability to keep loads going when power is not being generated from the sun.
Okay, great. We're at the top of the hour, so I want to respect everybody's time. There's probably a few more questions that we can respond to directly after this. So just wanted to kind of put a final point out here. I believe Brian just dropped in the chat. If you want to schedule a meeting with us, I think you can grab that there. Another way to get a hold of us is we do have a designated, what we call our architect hotline, design@aimbridgeenergy.com. If you want more information on our AIA courses that are coming up, please email us at that email address. And then, of course, you can always find us on LinkedIn, website, and we even have an old-fashioned phone number you can call if you want to reach out to us that way. So we'd love to talk with you more and get into some of the specifics of your projects and questions you might have. So obviously, free consultations, just like to get to know your projects and your needs in the marketplace. So with that, we will sign off. Thank you, everybody, so much for attending. We appreciate your time and hope everybody has a great day. Bye.
Thanks for attending.
Great, thank you.